Next up, we have a weather update and presentation by Bryan Williams, the state meteorologist for the Florida Forest Service. So 1 second as we trade out slides. And Bryan, go right ahead and share your slides.
And I know it says 30 minutes on the program. I don't know if I'm going to actually get to 30 minutes with this, but we shall see. So, my presentation is going to be kind of in two parts. We'll just talk about the forecast in the first half, and then the second half will be about understanding what the dispersion index is. So for those of you who don't know how I usually like to do my forecasts, I usually start by talking about the present a little bit and where we are in the season, and then after that, I'll go into what to expect for the future. So as you can see for the outline here, and again, at the second half, we'll be talking about dispersion. So where have we been so far in 2021? So luckily, right before the meeting, the data for October came out. So I was actually lucky enough to incorporate this. So what you're looking at here is where we were ranked for the average temperature. So this is including both your minimum and your maximum, so your lows and your highs. And for the most part, the state as a whole, we're right now in the one of the top 10 warmest years that we've had, pretty much going back as far as the late 1800s. There are a couple of cool spots. You can see Escambia, Santa Rosa, Holmes, and Jackson were pretty close to normal. The other counties in the region were within the top third warmest. And the further you got towards the peninsula, you actually got to the little more on the warm side. So average maximum temperatures, and this actually kind of surprised me a little bit. You can see the cooler colors, so that means that the max temperatures were actually on the lower end. Of course, the further you go down the peninsula, the warmer you got. But you can see there are actually some blues. So Leon, Jefferson, Hamilton, again, Escambia and Santa Rosa were in the lowest third coldest maximum temperatures through the year coming through October. But this is what actually pushed the overall average, and this is your average minimum temperatures. As you can see, the state as a whole was close to the top 5 warmest minimum temperatures. So this basically means our nighttime temperatures were pretty much on the warm side. The Panhandle, parts of the coast, and up towards Jacksonville, so Nassau, Baker, Bradford County, were a little on the cooler side, but you can see those orange colors. You can see that it pretty much dominates the region. And then with precipitation, it was pretty much a tale of two Floridas. The northern half of the state were on the wetter end of the spectrum, and the southern half of the state, you can kind of see that towards the bottom there, or on the drier end. So here in this region, again, North Florida was on the warmest, and the higher numbers were actually towards the Panhandle. So you can see those darker teals in areas, Escambia, Santa Rosa, again, Okaloosa, Walton, Franklin, and so on and so forth. So for drought, we've actually haven't really seen too many drought impacts this year. This is as of November 2nd. The latest drought index for this week won't come out actually until tomorrow. But as of November 2nd, again, the state's pretty much drought free. Have a little bit of an abnormally dry area up near Jacksonville, but other than that, the state of Florida, there are no drought areas in the state of Florida. And it's also worth noting that, yes, we're still in hurricane season. The season actually ends at the end of this month on November 30th.
Hey, good morning.
Good morning. How are you? You sound better.
Yeah, I think my throat's definitely.
Not sure who had their mic unmuted. So as I was saying, so 2021, so the 2021 season ends at the end of this month on November 30th. And we have actually gone through every name on the list. And I have Elsa, Fred, and Mindy highlighted because those were the storms that affected Florida. And we'll get into that a little bit later. So this is the current map as of 7 o'clock this morning. And you can see there is an area that the National Hurricane Center is tracking. It's not expected to impact the US or Florida for that matter, but it could become subtropical. And if it does, it of course will gain a name. Now, something that they're doing a little bit different this year is we're not going to the Greek alphabet as we had been doing in the past. We're actually going to a new list. They just started this year. And the reason why they're doing that is because some Greek letters are very difficult to pronounce in other languages. So instead of going to the Greek alphabet, we're basically going to go to another list of names. So if this system actually develops into something subtropical, it will actually be called Adria. And this list actually will function basically at like any other name list. So if there is a significant storm, that name will be retired and replaced with a new name. The only difference is that this auxiliary list actually will carry over into future seasons rather than going into a rotation of a list rotation as we do with our usual list. So as I mentioned earlier, there were 3 storms that directly impacted Florida. In July, we had Elsa. Elsa at its maximum intensity was a Category 1 hurricane, but it didn't affect Florida as a Category 1 hurricane. It made landfall just south of Perry in Taylor County on July 7th, actually as a tropical storm. About a month later, we had Tropical Storm Fred. Fred made landfall near Cape San Blas on August 16th. And then a month after that, we had Tropical Storm Mindy, which became a tropical storm not too long before it made landfall. It made landfall near Apalachicola on St. Vincent Island on September 9th. So overall, this year, even though it has been active, not too many storms affected the state. We only had 3, and neither of them were hurricanes. So now let's go into the future. So this is the actual forecast. I'm going to be going basically into the spring of next year. So starting in the winter, as you can see with seasonal temperatures, we're looking once again at above average temperatures and below average precipitation for the winter. And the reason for that, and I'll get into this a little later, is we're currently in La Nina. So La Nina is, for the Southeast, usually means a drier and warmer winter. And the models tend to agree with this. Going into the spring though, above average temperatures, once again, are going to continue. The difference here is going to be your precipitation. We're actually looking at maybe a near normal precipitation season for the spring. So this is telling me that La Nina will likely be transitioning into this in the spring, probably going back to a more of a neutral phase. Again, it's a little too early to tell, but that's what the early pointers are telling me here. So as I mentioned, La Nina is present and is forecast to last at least through February of next year. La Nina usually means warmer and drier conditions for the Southeast as a whole, including Florida. Again, the current forecast, as you saw, reflects that pattern. And because of this, I'm putting the chances of drought developing at about a moderate to high level, with the best chances of drought development happening in the peninsula. And that's what's shown here. So this is the drought outlook going through the end of January. And you can see the most of the peninsula is in that yellow, meaning drought development is likely. North Florida right now, there is no, they're saying no drought, but again, with La Nina, I'm kind of expecting that to change between now and say the end of the year, and that yellow likely creeping up just a little bit. So going into that, if we're talking about drought, we're going to look a little bit at wildland fire potential. And what this is, all this is just a measurement of, it's just a measurement of the likelihood of a significant wildland fire event, whereas you would have to bring in resources from outside of the region. So December, we're looking at basically normal wildland fire potential, but going into January, that's when things are looking to change. You can see now that above normal region basically trickling down the peninsula. And in February, it basically covers the entire eastern half of the state. So just in summary, we're looking at above average temperatures through the winter and the spring, below average precip through the winter. And again, those two you can likely link to La Nina, I'm sorry. Elevated wildfire potential possible beginning as early as January of next year. And La Nina is forecast to last through at least spring of next year. So with that, I want to take a little bit of time and talk about the dispersion index. So we can go into just talking about the dispersion index, but we need to first understand what dispersion is as a whole. So dispersion is basically the process in which the atmosphere transports pollutants or particulates away from its source. So at a smaller scale, you can kind of think of it this way. You've got a dusty cabinet and you're using your feather duster to basically dust the cabinet. So so what you're doing is you're basically dispersing dust from the cabinet. So dispersion actually depends on two things mostly. So your winds and your stability. So winds is horizontal movement of air. So you're looking at a weather forecast and you see, okay, so you've got a north wind, your winds are coming out of the north at 3 miles an hour. So those are your winds. And then you also have atmospheric stability. And atmospheric stability is basically your vertical movement of air. So winds are on the horizontal plane and stability is your vertical plane. And stability is usually what goes into making those towering clouds. So basically your thunderstorm heads, your thunder heads, cumulonimbus clouds. And then as a rule of thumb, generally, stronger winds and an unstable atmosphere usually means you're going to have a high dispersion. As I said, stronger winds is pretty self-explanatory, and an unstable atmosphere, that means that air is going to rise pretty easily. So we have the dispersion index, and the dispersion index was developed by Labdus. I'm not going to try and pronounce his first name. Yes, it's Leonidas. Leonidas Labdus developed the atmospheric dispersion index in the mid-'80s. And the purpose of it was to help assess the impact of prescribed burning activity and the impacts on air quality. And he based this model on what was called the climatological dispersion model. And the index is actually based on activity within a 50 by 50 kilometer area. So I think just doing quick math in my head, I think that's about between 5 and 7 miles in 5 by 7, or between 5 and 7 miles by 5 and 7 miles. So what goes into deciding the ADI? So we already talked about winds. You can see those two bullet points at the bottom, but you also look at mixing heights and transport winds. The transport winds are pretty self-explanatory. They're winds used to transport particulates. And then the mixing height, think of the mixing height as kind of like a pot lid. So you've got smoke rising. The mixing height is where your winds are going to be high enough that that smoke is going to have a hard time rising. So again, like I said, think of it like a pot lid. Smoke hits the top of the lid, and it's just going to just basically spread out horizontally rather than vertically. It's going to move horizontally rather than vertically. So Florida actually has two tables we use for ADI, one for the daytime and one for the nighttime. And the reason for that is because mixing heights at night are usually a lot lower than they are during the day. Both tables start at 0 and they go on forever. Your difference is going to be in the breakpoints, and we'll talk about those tables right now. So this is the daytime ADI chart. And again, like I said, it goes from 0 to infinity. 0 to 20 is going to be your pore dispersion. Usually we don't really have air stagnation problems here in Florida. It rarely happens, but if it's persistent, then you have a chance for that air stagnation to happen. 21 to 40 is poor to fair. 41 to 60 is generally good, and so on and so forth. Control problems usually happen when your dispersion is at about 75, 76. And control problems are usually expected when it's above 80. And you can see the nighttime ADI chart is a little bit, like I said, it's different. You can see for the breakpoints, for 1 is a lot lower. It only goes from 0 to 8. But again, like the daytime one, it technically goes to infinity, but you rarely see at night, you rarely see dispersion over like 15. But you can see the descriptions. And then just to close it off, we do have ADI maps on our website. The URL is listed there. That's the direct URL. But if you just do fireweather.fdax.gov, you should actually go straight, fireweather.fdax.gov/weather. You should go straight to it'll take you to the temperature map, but at the top, there's going to be some maps that you can use, or some links you can use. One of those links is a dispersion index, and it'll take you to this map. And the key for this map actually will update depending on what time of day it is. So when I got this one this morning, it was using the nighttime index. And actually by now, the map should have updated and it'll actually go to the daytime index. And again, there is the direct link to get to this map. And with that, I think that's all I have. Yeah, so there's my contact information. I'll leave this up for a little bit and I'll actually go back in a bit to so that I can give you that link again to the ADI map.
All right, well, thank you, Brian. Folks, we have time remaining in this slot on our agenda. So if you have questions for Brian, please go ahead and type them in the Q&A tool in Zoom. You'll see a box on your screen that says Q&A. You can click on that at the bottom and type in your question, and we'll get those to Brian and see what he has to say. If you see other questions from other participants that you would like us to try and address, there is a little thumbs up button in the Q&A, and if you want to go ahead and click on that thumbs up, that'll help us to get an idea of the questions that you would like us to try and get to. So Brian, we already have a question that came in from Ross, and I'm going to read it aloud. It says, Ross says, are drought conditions determined relative to average rainfall for a particular area, or is there a drought threshold that applies across the entire U.S.? He continues, in other words, could two areas of the U.S. have the same annual rainfall and have one area classified as being in a drought, while the other is not? That's a good question, Ross.
Yeah, that's a very good question. So drought really depends on the area. So, for example, here in Florida, we get a lot more rainfall than out west, because there's you got your deserts in Arizona, you got deserts in southern part of Oregon. Of course, usually get a lot less rainfall than Florida. So their drought thresholds would be different than what we see here in Florida. So it differs. It really does differ per region. So just looking at the question here.
Yeah, we had a question that came in
Yeah.
from Brian, and Brian says, he says, why is control an issue above 75? Yeah, could you talk about that? You had mentioned that at dispersion above 75, things can get a little bit squirrely.
Yeah, and the reason for that, simply put, is the winds. Because usually when your dispersions are in the 50 to 60, usually that means you're going to have strong winds somewhere, whether that's in the transport winds for that day, the surface winds for that day, or even could be a medium to low mixing height. So it really just kind of depends on that. And the reason that I say control problems are possible past 75 is, again, it's due to the winds. If you have strong winds, especially at the surface, that if you have a private fire that day or any kind of fire, that fire is going to move because the fire is going to be wind driven.
We had a question that came into the chat window. We will remind you, please, to put those questions in the Q&A tool in Zoom so we can all get to them. But I do want to see if you could respond to this from Walter. And Walter says, is there any particular reason for the very low dispersions in the Florida Panhandle in the last 3 weeks?
Low winds. I mean, we've had high pressure basically dominating the Southeast after these fronts have come through. And because of that, the winds have basically been very low to almost non-existent. So again, that is pretty much what it is in a nutshell.
All right, here's a question in the Q&A from Chris. And Chris says, could you explain the stability class values that are found in some fire weather forecasts?
All right, so the stability classes actually was requested by the folks in Georgia. If you notice especially some of the National Weather Service county warning areas that go into Georgia, like Tallahassee and Jacksonville, and I think Mobile does as well. No, I can't remember. Actually, no, Mobile doesn't. So it's just really Tallahassee and Jacksonville that cover parts of South Georgia. That was actually requested by the folks in Georgia. But really, stability class, you look at an index and you set up breakpoints using that index. And you're usually, I think the higher the stability class, the more stable you are, I think is how it works. But again, like I said, it was requested by the folks in Georgia. Not really, I guess it really doesn't really apply too much to Florida, but again, it's useful to have.
All right, here's another question in the Q&A from Nathan. And Nathan says, it seems like there was an increase in number of days with dispersion above 75 this past winter in spring compared to recent past years. So high dispersion last winter and spring. Is there something that you've seen as well? So is that something you noticed last year? Could you talk about that?
Yeah, it is something that I haven't noticed about that. It's again, really the reason for it is during the fall, during parts of winter, during parts of spring, you have fronts that come through, and the fronts usually your dispersion is going to be really high along those fronts. Those are usually when you see your 80s, 90s, sometimes triple digit dispersions is usually just as a front comes through or just before a front comes through and as it's pushing through. And then usually after that, that's when you see that big dip in dispersion. So it just really depends on how many fronts or what fronts come through. And like the, what's the word? The frequency of it.
All right. Well, Brian, we appreciate your presentation this morning. Marinelle put the link to the Florida Forest Service fire weather page and the ADI map in the chat window. So if y'all want to get to that, it's there. Brian, if you'll go to your last slide real quick, let folks copy down your email address if they have additional questions for you. It's there on the screen. And